Hi everybody, it's Miss Moncrief again, back at you today with another video. This time we'll be discussing the interior angles of triangles. So let me get my screen shared with you guys so we can get started. There we go. Okay, so our lesson objective for today is students will be able to solve for missing interior angles involving triangles. We're going to learn two theorems today, the first of which is called the triangle angle sum theorem. Let's copy this theorem down in our notes. And you're going to copy down what I put inside this box, okay? The blank of a triangle add up to 100. Ooh, the interior angles of a triangle add up to 180 degrees. I decided not to give you the answer, then I decided to give you the answer. So I'll just give you the answer. The interior angles of a triangle add up to 180 degrees. So here we have a visual representation. The vertices are labeled ABC, that's triangle ABC. So that's angle A. And if you add that with angle B, and if you add that with angle C, all together, it's going to add up to 180 degrees. Okay, so when you add all the angles in the triangle, of course, the triangle has three sides, three angles. Those three angles add up to 180 degrees. Let's look at some examples, some basic examples. Here we have a triangle AMT. Again, you name the triangle by the vertices. And we're missing the measure of angle T. So what we can do is we can build an equation just like we saw up here. If we add together angle A plus angle M plus angle T, that should equal 180 degrees. Angle A is 27 plus angle M is 82 plus angle T, we don't know that one, so I'm just going to use a variable T equals 180. Now we're going to put this equation into Math Papa, and it will give us our answer. So I'll do the first one with you. It was 27 plus 82 plus T equals 180. T is 71. So the measure of this missing angle is going to be 71 degrees. And we can check our work. That's what I love about this, 71 degrees. If you add 82 plus 71 plus 27, you should get 180. And we do. So that is correct. When the problems are really, really basic like this, there's another way you could do it also. Basically, if the total degrees in the angle is 180, you start with 180 and you just subtract 71, then you subtract 27. Sorry, not 71. You subtract what's given. We start with 180, we subtract 82, and we subtract 27, and that will still give us 71. So we could do it that way too. I like to do it this way because when you get to more complex problems involving algebra and missing variables and things of that nature, you want to have a habit of adding them up and making them equal to 180. Okay, in this next example here, we have here a right angle. We know a right angle is 90 degrees. So that's not unknown. We know that. It's labeled. This is unknown though. We don't know how much the measure of angle D is. But angle D plus angle G plus angle O should equal 180 degrees. We don't have a value for D. I'm going to use D. Plus 90 is the value of angle G. Plus 41 is the value of angle O. And that should equal 180 degrees. Okay, Sorry about that. Let me get my screen back up. And we're going to pick up where we left off. Okay. So the answer for the second example was 49 degrees, I believe. Let me just make sure. Yeah, 49 degrees. So D equals 49 degrees. Okay, now these down here are gonna require a little bit more work. Let me zoom in on this one. So in this problem here, we are missing, well, they want us to find the measure of angle E right here, okay? We're given angle D is 40, and we know that there's a triangle in here. Let me trace the triangle. And we know we need the 3 interior angles. So we have the unknown, we're given one. We need this one to be able to find that missing one, right? We don't have it directly, but we do have an angle adjacent to it. We do have part of the linear pair. So if we remember that when 2 angles form a straight line, they are a linear pair and they should sum up to 180 degrees. So I'm going to do 180, take away 117. And that is going to give me the measure of that angle on the inside of that triangle. And that answer should be 63. So this angle right here is 63 degrees. Now I can work with the inside of the triangle. I can do angle D plus angle E plus angle F. And I add these in no particular order. Remember, 1 plus 2 is 3 and 2 plus 1 is 3. Order does not matter when you add. But we know that should add up to 180 degrees. Angle D is 40 plus angle E is unknown. I'm gonna use E as my variable to represent the value of that angle. Plus angle F, we said was 63 degrees equals to 180. When I put this in my equation solver, I'm going to get E equals 77 degrees. The measure of angle E is 77 degrees. And again, we could check it. 40 plus 73 plus 63 is 180, so that answer is correct. This one here is even more complex. Let me erase this one. It's nothing that we don't know, but we do need to use a few steps to get to our answer. This one wants us to find the measure of angle 2 and angle 11. So I'm gonna go ahead and highlight that. Angle 2, I'm looking for that. Angle 11, I'm looking for this, okay? So let me draw my triangle here. There's my triangle. But we only have one of the angles. We only have that 80 degrees right here. We don't have the 2 or the 11. Which one do you think we could get more easily? Which one has something next to it that we could work with? The 2. So angle 2 and angle 1, again, form a linear pair. They equal to 180. So 180 minus 140, that's going to leave behind 40 degrees. So this angle here is 40 degrees. So now I can work with that green triangle because I only have one that's missing. You can work with it as long as only one angle is missing. So angle 2 plus angle 9 plus angle 11 has to equal 180 degrees based on our theorem. Angle 2 is 40 degrees. Angle 9 is 80 degrees. And angle 11 is unknown. I'm going to call that x equal to 180. So my answer for x, when I put this in my equation solver, it's going to give me 60 degrees. So my answers are, remember, what's the measure of angle 2 and the measure of angle 11? Angle 2, the measure of angle 2 is equal to 40 degrees. We found that using linear pairs. And the measure of angle 11 is equal to 60 degrees. And we found that using the interior angle sum theorem. Okay. This one here. My God. This one looks complex, but not for us because we have our equation solver. We just gotta know how to set it up. So I don't have any vertices in this one. I'm gonna make some up. That's going to be A, that's going to be B, that's going to be C. I know angle A plus angle B plus angle C has to equal what? 180 degrees in a triangle. Angle A is 71 degrees. I'll write my degree symbol. I'll do that. Plus parentheses 6x minus 1 plus 50 equals 180. Put this in your equation solver. And we're going to get x is equal to 10. So x is equal to 10 degrees. Now, what if they told you in this question, find the measure of angle B? What if they wanted this whole angle? Then you would just substitute 6x minus 1. You would change the x to 10 and use parentheses, and you would get 59 degrees. So x by itself is 10 degrees, but the measure of this whole angle here would be 59 degrees, okay? Last one. Again, we see we have a right triangle because the right angle is labeled. Our right angle is 90 degrees. So I'm not going to draw the vertices this time because I kind of have my idea down. My idea is that one angle plus another angle equals 180 degrees. 3 angles in the triangle, right? The first one is going to be 2x plus 1 plus the second angle, I'm going to use 5x plus 5. And the third angle, I'm going to use the 90. And that should all equal 180. Again, order does not matter when you add. So you could add these up in any order that you want. I'll work this one out for you. 2x plus 5x gives me 7x. 1 plus 5 plus 90 is going to give me positive 96 equal to 180. Now I'm going to subtract 96 on both sides. 7x is going to be equal to 84. Divide both sides by 7. And x equals 12 degrees. So the missing, well, the value of the variable in this problem is 12 degrees. If they asked you to find either of those angles, you would just substitute wherever you see an x, you would put 12, and you would get the answer of either one of those angles. Okay, the next thing we're discussing today, and it all goes together. You're going to see in a second that it just kind of builds upon the next one, is the Isosceles base angle theorem. And that theorem states that if two sides of a triangle are congruent, then their opposite angles are also congruent. So by definition, an isosceles triangle has two congruent sides. The third may or may not be congruent. So if two of the sides in the triangle are congruent, what they're basically saying is that the angles opposite them are also going to be congruent. So let's look here. We have, let me get my highlighter. We have side DE is congruent to side DF, right? So the angle opposite side DE is angle F. The angle opposite side EF is angle D. Those two angles are also congruent to each other based on this theorem, right? So let's look at some examples of what this would look like. First example, we have a triangle that has 116 degrees in the vertex at the top, well, in the angle at the top, and then both of these say B. This is an isosceles triangle because B, whatever B is going to be congruent to B. It's congruent to itself, right? So this is an isosceles triangle. So this is very similar to the other one. We know that one angle plus another angle plus the third angle of a triangle has to equal 180 degrees. So I'm going to use my 116 plus B, and that has to equal 180 degrees, okay? We're going to put this in the equation solver, make it quick for ourselves, and we're going to get B equals 32 degrees. Next one. Now this one wants you to solve for X, and it wants you to solve for Y, okay? But here we go again. these two sides are congruent, right? Because this is an isosceles triangle. You know that because these little tick marks right here. When you have those markings, any sides that have one marking are going to be congruent to each other. If they had two markings, those sides will be congruent to each other. So because those two sides are congruent, these two angles are congruent, right? So off the rip, we know that the measure of angle Y has to be 52 degrees because these two angles have to be congruent because this is an isosceles triangle. So angle Y is 52 degrees. Now, put that in your picture. When you find something, you should always put it in your picture because that will kind of help minimize the confusion and help you get to the next answer quicker, okay? So again, box plus box plus box equals 180. 52 plus 52 plus 14x plus 6 equals 180. Put this in my equation solver and I am going to get x equal to 5 degrees. Next one. Now, this one is not drawn to scale, but remember those markings I told you about. When you see that one tick mark, that means they're congruent. So this is an isosceles triangle. Think of it backwards. Because the two angles are congruent, the two sides have to be congruent. They're just not labeled as such, but it's okay. So because these two angles are congruent, the best way we're going to solve for x is by remembering what congruent means. Congruent means they're equal to each other. So we have one angle equal to the other one, okay? So 4x plus 12 has to equal 5x minus 3. Subtract 4x, subtract 4x. 12 equals x minus 3 plus 3 plus 3. X equals 15 degrees. Again, you could just put that in the equation solver. Now this one here, I took from the ACP. On the ACP, they are going to want us to find the measure of angle JKL. In the do now, I gave you some angles and I had you name them based on the vertices. If you don't recognize where angle JKL is, you're gonna do all the work for nothing, you're gonna get the wrong answer, okay? So let's label that first, JKL. Here's J, here's K, here's L. This is the angle in which we're speaking of, this big angle here, okay? So both of those angles put together is gonna form JKL. Keep that in mind. Don't just find one of them and think that's your final answer. So we have here a triangle. We have two sides and we are only missing one. So I'm gonna call this one side, this one angle X. So 40 plus 70 plus X equals 180. 110 plus X equals 180. X is gonna equal 70 degrees. So again, on your picture, I'm gonna take away the X and I'm gonna go ahead and I'm gonna put 70 degrees right there. Are these linear pairs? Can I do 180 minus 70 to find this other piece right here? No, a linear pair has to form a straight line. This is not a straight line. So let's not make that a habit of doing that. What I do know though, is that this is a linear pair. So I can do 180 minus 70 to get this one, and that will give me 110 right there. That's 110. And if we like turn our paper and look at it, we know that this triangle, let me highlight it in a different color. This purple triangle here is an isosceles triangle because of those markings. So whatever this is gonna be equal to whatever that is, okay? So I'm gonna use a different variable. I'm gonna use y and y. If this is y, that's y because they're equivalent, they're the same. So y plus 110 is going to equal 180 degrees. 2y plus 110 equals 180. 2y is going to equal 70 because you subtract 110 on both sides. Divide by 2, y equals 35 degrees. So, what is the measure of angle JKL? Is it 70 degrees? Is it 35 degrees? Remember what I told you, go back to your picture. Make sure you label your picture. We said that we were looking for this big piece here, right? So that would be a combination of both 70 and 35. So 70 plus 35 equals 105 degrees. So the measure of angle JKL would be 105 degrees. One more. Again, remember that you are looking for JKL. I'm looking for this right here. So let's get this one first. X plus 44 plus 63 equals 180. Use my equation solver, and I'm going to get 73 degrees. X equals 73. I'm gonna try and spread into this bigger isosceles triangle right here. I'm trying to come here now. So I'm gonna say these are linear pairs. I'm going to do 180 minus 63, and that's gonna leave 117. So that's 117 degrees right there. Because these are congruent, these angles are congruent, we're gonna call both of those y. So 117 plus y equals 180. Put this in the equation solver. Y is going to equal 31.5. Is that right? Let me do this one by hand because I just want to make sure I'm telling y'all the right thing. 117 plus 2y equals 180. 2y equals what? 57? Where did I get 57 from? 53. Is it 53? It's 180 minus 117. 180 minus 117. 17, 3, 6, 63. And then I divide by 2. Half of 63 is 31.5. So y is equal to 31.5 degrees. And then to get my final answer, I combine 73 with 31.5 degrees. 73 plus 31.5 is equal to 0.54, 104.5. That's my answer for that last one. So as you can see, the second set of problems, they're basically the same as the first set, the interior angle sum theorem of triangles. However, when you're working with isosceles triangles, you just have to remember that if you see two congruent sides, you're gonna have two congruent angles. And you can use one variable to represent both of those angles and just add them together, make an equation, solve it, and you get your answer. That's all I have for you today. Bye.